Section 3, number 5. Is it possible to prove that the line M and N are parallel in these cases? If so, make sure you state the postulate or theorem that you would actually use. All right, to help you along, these are the major 3. There's one more that allows us to prove that they are parallel. But so to make sure they're parallel, it has to fit one of these. The F-shaped one, the Z-shaped one, or the U or C-shaped one. Okay? And these are its names. Make sure you write converse next to it. All right? So the first one, that looks like the letter F to us. So that is going to be our corresponding converse. So here's your F if you do not see it. Right here. They're both in the same spot. So we can say these are corresponding angles. You just also have to use the word converse here. All right, that's the key word, converse, because you're proving that they're parallel. Okay, next, these look like it is opposite, because take a look. You see how they're crossing, and they're both on the outside. So that would be your alternate exterior angles converse. Okay, that allows you to prove that they're parallel. Okay, next, let's see here. Well, here we can't slide them. You are only allowed to slide them if they're parallel. Here there is none, so none, so can't prove. Okay, you can't prove anything here. These are vertical, and you can't prove M is parallel N. Okay, so both C and D, we can't prove that they're parallel. All right, the only ones that we are allowed to prove parallel is A and B. A is because of the corresponding angle converse, and B is based on the alternate exterior angle converse. Please understand that there are 2 more. You could also use the alternate interior angles, and you also can use your corresponding angles converse as well.